12. Direct versus indirect derivation of existentials. Adding O to our list of rules enables us to show universals using indirect derivation. This particular use of O is really no big deal, since we already have a derivation technique that is, universal derivation that is perfect for universals. Whereas we have a derivation scheme show rule specially designed for universal formulas, we do not have such a rule for existential formulas. You may have noticed that, in every previous example involving VFV, we have used direct derivation. This corresponds to a derivation strategy, which is schematically presented as follows. Direct derivation strategy for existentials VFVDD. Fn VFVI, but now we have an additional rule, O, so we can show any existential formula using indirect derivation. This gives rise to a new strategy, which is schematically presented as follows. Indirect derivation strategy for existentials VFVI DVFV is DDVFVO. Many derivation problems can be solved using either strategy. For example, recall example 1 from section 8. Example 1 DDD strategy 1 XFX HXPR2 XFX PR3 XHX DD4 FA2, 05 FAHA 1, 06 hectares 4, 5, 07 XHX6. I example 1 IID strategy 1 XFX HXPR2 XFX PR3 XHX ID4 XHXS5 DD6 XHX4, 07 FA2, 08 FAHA 1, 09 hectares 7, 8, 010 hectares 6, 011 9, 10. Comparing these two derivations illustrates an important point. Even though we can use the ID strategy, it may end up producing a longer derivation than if we use the DD strategy instead. On the other hand, there are derivation problems in which the DD strategy will not work in a straightforward way. Recall that every indirect derivation can be converted into a trick derivation that does not use ID. In these problems, it is best to use the ID strategy. Consider the following example. Besides illustrating the ID strategy for existentials, it also recalls an important sentential derivation strategy. Example 2 1 XFX XGX PR2 XFX GX ID3 XFX GXS4 DD5 XFX GX3, 06 XFX ID7 XFX 8 DD9 FA7, 010 FA5, 011 FA10, 012 9, 11, I13 XGX1, 6, 014 GB 13, 015 FBGB5, 016 GB 15, 017 14, 16. I recall the wedge-out strategy from Sentential logic. Wedge-out strategy: if you have a disjunction, for example, it is a premise, then you try to find or show the negation of one of the disjuncts. We are following the wedge-out strategy in line 6. While we are on the topic of sentential derivation strategies, let us recall two other strategies, the first being the wedge derivation strategy, which is schematically presented as follows. Wedge derivation strategy AB at AB is DDAOBO. The strategy is employed in the following example, which is the converse of 2. Example 2 C1 XFX GX PR2 XFX XGX ID3 XFX XGXS4 DD5 XFX3, 06 XGX3, 07 XFX5, 08 XGX6, 09 FA1, 010 FA7, 011 GA8, 012 GA9, 10, 013 11, 12. Another sentential strategy is the arrow-out strategy, which is given as follows. Arrow-out strategy: if you have a conditional, for example, it is a premise, then you try to find or show either the antecedent or the negation of the consequent. The following example illustrates the arrow-out strategy. It also reiterates a point made in Chapter 6, namely, that an existential conditional formula, for example, XFX-GX, does not say much, and certainly does not say that some f is G. Example 3 1 XFX XGX PR2 XFX GX ID3 XFX GXS4 DD5 XFX GX3, 06 XFX UD7 FA DD8 FA GA5, 09 FA and GA8, 010 FA 9, and 011 XGX1, 6, 012 GB 11, 013 FBGB5, 014 FB and GB13, 015 GB 14, and 016 12, 15. In line 6 above, we apply the arrow-out strategy, electing in particular to show the antecedent. The converse of the above argument can also be shown, as follows, which demonstrates that XFX-GX is equivalent to XFX-XGX, which says that something is G if everything is F. Example 3 C1 XFX-GX PR2 XFX-XGX CD3 XFX-S4 XGX ID5 XGX-S6 DD7 XGX5, 08 FA GA1, 09 FA3, 010 GA7, 011 GA8, 9, and I12 10, 11. I note carefully that the ID strategy is used at line 4, but only for the sake of illustrating this strategy. If one uses the DD strategy, then the resulting derivation is much shorter. This is left as an exercise for the student. The last several examples of this section involve relational quantification. Many of the problems are done both with and without ID. Example 4. When there is a freshman who respects every senior 2. Therefore, for every senior, there is a freshman who respects him. For example 4. DDD strategy 1 XFX and Y psi RXY PR2 XS XY phi and RIX UD3 saw Y phi and RIA CD4 saw as 5 Y phi and RIA DD6 FB and Y psi RBY1, 07 FB6, and 08 Y psi RBY6, and 08 saw RBA 8, 09 RBA4, 8, 010 FB and RBA7, 9, and I11 Y phi and RIA 10. I example 4 IID strategy 1 XFX and Y psi RXY PR2 XS XY phi and RIX UD3 saw Y phi and RIA CD4 saw as 5 Y phi and RIA ID6 Y phi and RIA S7 DD8 Y phi and RIA 6, 09 FB and Y psi RBY1, 010 FB9, and 011 Y psi RBY 9, and 012 FB and RBA8, 013 saw RBA11, 014 RBA4, 13, 015 FB RBA12, and 016 RBA10, 15, 017 14, 16. I note that this derivation can be shortened by 2 lines at the end. Exercise for the student. The previous problem was solved using both ID and DD. The next problem is done both ways as well. Example 5. When there is someone who doesn't respect any freshman 2. Therefore, for every freshman, there is someone who doesn't respect him/her. Example 5. DDD strategy 1 XY phi and RIX PR2 XFXY RXY UD3 FA Y raise CD4 FA as 5 Y ray DD6 Y phi and RIB1, 07 Y phi and RIB6, 08 FA and RAB7, 09 FA RAB8, and 010 RAB4, 9, 011 Y ray 10. I example 5 IID strategy 1 XY phi and RIX PR2 XFXY RXY UD3 FA Y raise CD4 FA as 5 Y ray ID 6 Y ray S7 DD8 Y ray 6, 09 Y phi and RIB1, 010 Y phi and RIB9, 011 FA and RAB10, 012 FA RAB11, and 012 RAB8, 014 FA 12, 13, 015 4, 14. The final example of this section is considerably more complex than the previous ones. It is done only once, using ID. Using the ID strategy is hard enough. Using the DD strategy is also hard. Try it and see. Example 6.1 Every freshman respects Adams 2. There is a senior who doesn't respect anyone who respects Adams 3. Therefore, there is a senior who doesn't respect any freshman 1 XFX RXA PR2 XSX and Y RIA and RXY PR3 XSX and Y phi and RXY ID4 XSX and Y phi and RXY is 5 DD6 XSX and Y phi and RXY 4, 07 SB and Y RIA and RBY2, 08 SB7, and 09 Y RIA and RBY7, and 010 Y RIA and RBY9, 011 SB and Y phi and RBY6, 012 SB Y phi and RBY11, and 013 Y phi and RBY8, 12, 014 Y phi and RBY13, DN15 FC and RBC14, 016 FC15, and 017 RBC15, and 018 FC RCA1, 019 RCA16, 18, 020 RCA and RBC10, 021 RCA RBC20, and 022 RBC19, 21. 023 17, 22. What strategy should one employ in showing existential formulas? The following principles might be useful in deciding between the two strategies. 1. If any strategy will work, the ID strategy will. The worst that can happen is that the derivation is longer than it needs to be. 2. If there are no names available, and if there are no existential formulas to instantiate in order to obtain names, then the ID strategy is advisable, although a trick derivation is still possible. 3. When it works in a straightforward way, and it usually does, the DD strategy produces a prettier derivation. The worst that can happen is that one has to start over, and use ID4. If names are obtainable by applying O, then the DD strategy will probably work. However, it might be harder than the ID strategy. I conclude with the following principle, based on 1-4. If you want a risk-free technique, use the ID strategy. If you want more of a challenge, use the DD strategy.